Hello. Okay, so we are live. So we are a little late today, and the reason for that is because I went to have an eye test. Okay, and let's solve this problem. Maybe we'll solve one problem only today. I will have a short stint, 15-20 minutes. Okay. We are solving this problem, right? So, okay. What is this? Oh, I was writing the BFS code, right? Sorry. This is the input. Do we need to go into that Miro? I don't think so, because we already discussed the solution. I think it is very similar to the last problem that we did, only that we need to keep track of the choices that we made this time. So we will have two another, like for example this buffer, right, that we discussed yesterday. We will have two things here. Okay, we can have a parent array. Also we can have what steps we took. Okay, so for example, if we went to left, then the step will be L from that node. Okay, so yes, so basically to get to that node from its parent, what step did you take? That is the steps. Okay. And we need, of course, we need one more thing. We need a character array. It's not Java. Direction. This one -1 0. So in X you go -1, so it will be L. Okay. 0 -1. So in Y direction you go, so it will be down. And a 1 0 is right, and this one is U. So this is U direction. And distance, we don't need any distance. What we need is, we need to parent and character, right? So for parent, we need a 2D array. We need a 2D. Okay, so the steps will be character. Okay, so this is this. Size is S. We have Okay, so direction is this dx dy steps. We see. Okay, so we had steps. One more thing we need is that parent thing. So this coordinates parent is this. How do we store that? So we will have a mm, mm, a 2D vector with each storing a pair. That should work, right? Yes, that should work because it is a grid, na? So a 2D vector with each storing a pair. Size is same. Maybe I'm sure there is one. So instead of this, we will okay. Now, what to put inside this? We don't need this. We need this. Okay, we need this. And okay, so steps. The base, the start of A. There is no parent, so ij is this. No, ij it's a character, right? It's a character. So there is nothing. And for parent, ij is -1 and we take this, we will remove this. So first of all, if we find that this is not state, it's position. If this position is the end point, then we'll break out of it. And the steps, the step will be what? Let's see. We'll break out of it. Direction will be stored anyway there. Visited, if it is already visited, then we'll also break out. Yes, it will true. And okay, so here, if it is okay for ni and nj, and also it is not visited, and also the string value is either dot or this, oh sorry, this. Then in that case we will push the state. So q dot push the state, so ni and j. Also the parent of ni and j will be this post dot ff post dot ss. And the steps to reach this is whatever this is. Okay, so we are done here. And for reconstruction of the string, so while we'll have x is basically okay, we'll store the endpoint. So int pair end is equal to, we have a parent, and here in the end position end is basically position, and while n dot ff and y is n dot ss. So x is not equal to -1, and y is also not equal to -1. So we will do x is equal to parent x okay, and is not equal to -1. And is equal to parent n dot ff dot ss, and we will add steps dot ff and dot ss, and we will reverse all of the answer and return it. And this is here. Okay, so it will be BFS instead. There is no need for answer. I will break out of it. Bool flag is equal to false. Flag is equal to true. If not flag, continue. No, if flag. If not flag. If flag, then if false, then what will happen if false? This doesn't make sense. If break. If flag is true, then break. While loop is definitely taking it's while loop. Other than that, nothing is getting changed. Why? Maybe do this. Okay, so we have something now. So we will start from here. Okay, so this is minus 1, there is no parent. 2 1 is the parent for this, 3 1 is the parent for this, but it is not 3 1. 3 2 is the parent for this. This is not even 3, it is 0 1 2 1. It is okay, it is 2, no, then Parent for 1 1 will be 2 1, not 2 1, 1 2. I'm not sure how it is getting stored in the memory. I mean, how it is being stored in the memory. Hmm. This is correct. And don't this here. So we are not reaching B at all. We are not reaching B at all. Okay, so now we did reach. So 0, 1, 2. So 0, 1, 2, 3, 4, 5, 6. Okay. Okay, so 636, its parent is 36, parent is 36, so 26 it will be 36, for 36 it is 35, and then it is again 36. Why? Then it is again 35. Why? There is some issue with the code. Okay, so this logic is not correct, because the thing is, there are multiple ways to reach this cell, right? I'm not sure why. Yeah, there are different ways. I'm not sure why this is 35, which it should be. I'm not sure why this is 30. Okay, so this is 36. Okay. Yeah. Yes. So because of that, since for all four neighbors of a single cell, the parent can be same. Okay, but also can be different. Okay, so need to track that somehow. But how? How did I solve it in the past? Okay. Very same. Okay. If there are multiple paths, it is possible. This thing is Kobe. I will do this. This is just to and we have the start. We are looping it incorrectly. The basically this ending condition or the termination was not proper. There is no change. There is a change, and this is enough for this to work. Trull. So this is not correct actually. We cannot go down from A. So okay, so why did it so minus 1 0 minus 1 in x direction. So in okay, this is x now, so this should be y. This is x. Left up. No, it is also not wrong. It is also not correct. You just have to swap these two. So now L down, right up. Okay, this is correct. L down, right up. L down, right up. Okay, very similar. It is exactly the same as the last submission. So okay. We need to print this, then answer, and also this, right? And if this is the case, then we will return it. I think this is it. Returning and okay, yep. Building roads. Minimum number of roads required, and also determines which roads should be built. So basically you have to count the number of connected components, and then the answer will be basically how do you connect those components. So see, building roads. Building roads. Okay, wait a second, my stream. So building roads. So we have different cities. Okay, they're like n cities, n cities, and we have m roads. So maybe they are connected like this, and maybe they are connected like this. So basically we want to construct roads such that all of them are connected. So here if I connect this with this and this with this, this, okay, so you can see all of them are now connected. So how many roads needed to build is basically the number of components minus 1. Okay, and which road should be built now? So you can which road should be built? So basically we want any two nodes from, or any we just want to connect any two nodes from the component set. So we can give any two components from any two nodes from either, or basically no, not any two. We can get any one node from here and any one node from here. So see, when we do a DFS, okay, so whatever node we start from, we can have that as our the center point. Okay, and the next time the DFS starts, we will add that basically like this. Okay, so if we start, so let's say there was it wasn't connected, this wasn't connected and this wasn't connected. Okay, so it was like this. And so if we started DFS from this, if we started our DFS from this, so it will go to this and then this. Okay, let's say this is 1, this is 2, this is 3, 4, 5, 6, 7. The next time the DFS will start from 2, but it is already visited, so I will not touch it. I will go to 3. So 3 here is a node from which the DFS, a new DFS is starting, right? So we will store previous and whenever a new DFS starts, we will add this combination, the previous and current node from where the DFS is starting, to our answer array or whatever. We'll just, or we can just print it. So yeah, this is the logic basically. So copy it, paste it, and we'll clean it up a little because now we are not dealing with grid. So now it will be I0M. It is now the size is what, 10 to the power 5. So I will not do it here. So BFS is needed, so we will change from here. There will be a source. Okay. Of course, we just need to do BFS it. So this src is true for auto node in adjacent of src. If not visited this node, then do a DFS in this node with visited, otherwise do nothing. So we'll, the DFS is done, BFS we don't need, and this is done. Also adjacent dot resize n plus 1. This not work. Yeah, this will work. Okay. We need this. Okay, so now we will add this here. We'll also add this here. This is a one based indexing, so now we need the connections. So we can have a vector of pair, basically roots, and we will run a loop from 1 to n and check if it is not visited. If not, then we will have a previous. Okay, then previous will be set to if previous is not equal to -1, then we will add new rows. Previous and the current one will be connected. We'll have a DFS, this TF or okay. So this TFS will take the current node and the visiting array. Okay, so this is done, and at the end we will change previous to the current one, and now we will do previous dot size, and for auto I in previous cout. don't need this thing. Lot of silly mistakes. Yes, this should work. Yep, done. Message route. BFS and then storing the path. Same as the labyrinth one, but it is not a grid this time. Okay, so that was it for today. We solved 2 problems, and now it is 8:30, and I need to go have dinner. So, so I guess this is it for today, and we'll meet tomorrow. Yep, we'll meet tomorrow. So, yeah.